Humans have been trapped in a cage all their lives. We think this box is the whole universe. But physicists are not right. There must be something outside the cage. They said, humans may live in an 11-dimensional universe, but it can only perceive 3 dimensions. It's like an anti-line on a wire. I thought the world was just a line. I don't know that I have missed the entire 3-dimensional space. What's even more terrifying, those dimensions that we cannot see. It may be hidden under your feet and in your hands. In every point of your body. They were there all the time. You can never touch it. 3-dimensional space plus 1-dimensional time. It is 4-dimensional time and space. But the equations of physics keep hinting. This is not quite right. In 1919, a German mathematician named Theodor Kresha checked Einstein's gravitational equation. One more dimension is written. It was originally a 4-dimensional spacetime equation. He wrote it in 5 dimensions. So something strange happened. The 5-dimensional equation can not only describe gravity. Equations describing electromagnetic forces are also automatically spit out. 2 completely different forces. It comes naturally from the same framework. Just because he wrote one more dimension, no one puts it together. There is no forced stuffing together. They themselves grew up together. Karuza was stunned at the time. He wrote in the paper, "This result has an indescribable beauty." He sent the paper to Einstein. Einstein was also very excited when he saw it, but he was a little hesitant. If there really is a 5th dimension, why can't we see? This problem has been stuck for 2 years. Later, another physicist, Oscar Klein. The answer was given. Klein said the 5th dimension may have rolled up. What does it mean to roll it up? We can imagine. A wire is pulled between 2 trees. You stand and look at it from a distance. A wire is a wire. It is 1-dimensional. Only length and no width. But when you get closer, you will find that the wire is thick. An ant can crawl around the surface of a wire. This is the direction of a circle. It is a dimension that we cannot see from a distance. That dimension of wires has always existed. Just because it's too fine, it is not visible from a distance. Klein said, the additional spatial dimension may also be the same. He exists but curls up very, very small. As small as an infinite number of times smaller than the nucleus. Of course, our eyes can't see. Existing instruments also cannot detect it. This explanation is mathematically self-consistent. Karuza and Klein together, it opened a new door to physics. Unified the different forces by adding dimensions. But not many people entered this door at the time, because in the 20s and 30s of the 20th century, there are more exciting things happening in physics. Quantum mechanics is exploding. Schrödinger, Heisenberg, Dirac-Paul, a bunch of geniuses studying atoms and electrons. Every month brings new breakthroughs. Compared with, the idea of extra dimensions seems too abstract. It cannot be directly verified. So the Karuza-Klein theory was put on hold. It has become a niche idea in the corner of physics. But the seeds have already been planted. In 50 years, this seed will grow into a forest. Late 60s, physicists studied the strong nuclear forces in the nucleus. Strong nuclear force is the force that holds protons and neutrons together. But the action distance is very short. At that time, it was not very clear what its essence was. Several physicists have tried a new idea. They don't put protons and neutrons. These particles are treated as a point. Instead, it is treated as a very short string. Vibrate there. This idea sounds a bit strange, but mathematically it's beautiful. Different vibration patterns correspond to different particles. The strings vibrate faster. It shows that a particle vibrates more slowly. Manifestation is another example. All basic examples. They are all different formations of the same string. This is the prototype of string theory. The original string theory was used to study strong nuclear forces, but physicists soon found out this theory can do much more than that. It could be a more ambitious framework. It can fit all the forces and all the particles into it. So everyone began to seriously study string theory. Then trouble came. The equations of string theory are very complex. Physicists found out when calculating, if space has only 3 dimensions, the equation will have the so-called anomaly. Simply put, it is a mathematical contradiction. For example, the probability does not add up to 1, or energy can appear out of nowhere. These contradictions mean that the theory is wrong, or incomplete. Physicists have tried various methods to eliminate these anomalies. All failed. Until someone thought of it, Karuza and Klein's dimensional theory. As a result, the plus dimension is O. When the dimensions of space increase to a certain number, all anomalies disappeared. The equation becomes perfectly self-consistent. The question is how many dimensions need to be added. The earliest version of string theory is called Bose string theory. 25 spatial dimensions are required, at time for a total of 26 dimensions. Later, physicists improved the theory, introduced a mathematical structure called supersymmetry. The number of dimensions has dropped, but there are also non-spatial dimensions, at time for a total of 10 dimensions. Then came the mid-90s. Someone found out these different versions of string theory. In fact, it can be unified into a larger framework. It's called Theory M. The M theory requires 10 spatial dimensions, at time for a total of 11 dimensions. This is not decided by physicists patting their heads. It's not that anyone thinks 10 dimensions are better than 26 dimensions. 10 dimensions are forced out by mathematical equations. You don't give him so many dimensions. Theory cannot exist. The math is telling us either the extra dimension is true, either the whole string theory idea is wrong. Now the problem becomes, if there really are 6 or 7 additional dimensions of space, then where are they? Why don't we feel it at all? Physicists have given several possible answers. Each corresponds to a different model. The first is still the old idea of Karuza and Klein. The extra dimension has been tightened. Compacting is to roll into a small shape, hidden in every point of space. You stand anywhere. At that point under your feet, I'll roll up 6 or 7 extra dimensions. But they are too small, as small as 10 to the power of 35. This scale is called Planck length. It is more than 20 orders of magnitude smaller than the nucleus. On such a small scale, we don't see any of the instruments we have, so the extra dimension exists. But you will never bump into them. This model is mathematically feasible. Physicists can even calculate it. What shape the extra dimension rolls into, what kind of laws of physics will arise. There is a special type of shape called Kara-Picchu-popular. It is especially important in string theory. Different Kara-Picchus are popular, corresponding to different particle types and force strengths. But this begs a disturbing question. There are many varieties of Kara-Picchu popularity. There may be as many as 10 to the power of 500. If each corresponds to a version of the laws of physics, then our universe is just one of them. There are countless parallel universes next to it. The rules of physics are completely different from ours. The second model is a little bolder. Late 90s. 3 physicists came up with a new idea. According to their names, the initials of the word are called Ed model. They asked if the extra dimension had to be that small. What if they are actually quite big? For example, it's as big as a millimeter. In the world of particle physics, millimeters are huge. The scale of the nucleus is 10 to the power of 15. Millimeters are 12 orders of magnitude larger than the nucleus. If the extra dimension is as large as a millimeter, why we still don't feel it? The answer to the model is that we are stuck. Imagine having a table. The table surface is two-dimensional. An ant can crawl around on it, but ants can't leave the table. It is trapped in this two-dimensional world. There is obviously a three-dimensional room above the tabletop, but ants don't feel it. A module says, we may be two. We live on a three-dimensional demon. All particles and forces are trapped in this demon. You can't get out of these three dimensions. It's like ants can leave the table. But gravity is different. Gravity is the curvature of space-time itself. He will not be trapped by demons. Gravity can leak into additional dimensions. This explains why gravity is so weak. Its strength would have been enough, but most of it leaked into the extra dimension. We only feel a small part of what is left, like water from a faucet. It should all flow into your cup, but there is a hole in the cup. More than half of the water leaked out. If this model is correct, then we should be able to find evidence of gravitational leakage at very small distances. For example, below millimeters. The behavior of gravity should be different from Newton's laws. It should decay faster. Because on that scale, gravity began to leak. Physicists really did this experiment. They built very sophisticated instruments, measure gravitational force over tiny distances. Up to now, it measured until about 50 microns. No anomalies have been found in the meter scale. This means, if an additional dimension exists, they are either smaller than 50 microns, or hide deeper. But the experiment continues. Every step forward, it is the range where the additional dimension may be hidden. Shrink one circle. The third model is more ingenious. 1999 to physicists, Lisa Randall and Raymond Sandrum, an idea called prying additional dimensions was proposed. They say that extra dimensions are not necessarily flat. It may be curved. What does it mean? You imagine a rubber film. You stretch it, twist it, and bend it. Grind in different places. The scale is different. Some places are tight. Some places are loose. Randall and Sandrum said, this is how the extra dimension may be bent. Gravity is concentrated in some places, dilute in other places. This three-dimensional model of our life, exactly where gravity is greatly diluted. This model does not require additional dimensions. Very small, it can be quite large. But because the space itself is warped, we still don't feel it. What's even more powerful is, this model explains hierarchical problems, and it uses a very elegant geometric way. Physicists love this elegance. There is also a model called universal extra dimension. In the model of A, only gravity can enter additional dimensions. The other forces are trapped on our 3D mode. But the universal extra dimension model says, all forces and particles can enter additional dimensions. This leads to an interesting consequence. Each particle will have a heavier surface hydrogen. It's called Karuza-Klein stimulus state. These heavier particles are usually invisible, but it may occur in high-energy experiments. What's even more interesting is, these heavy particles may be dark matter. Dark matter is a big mystery in cosmology. We know the universe. There is a lot of invisible material in it, because their gravity is influencing the rotation of galaxies. But we don't know what dark matter is. If the universal extra dimension model is correct, dark matter, it could be the particles hiding in the extra dimension, the stimulating state. One theory explains two mysteries at once. It's tempting. So many models have been said. You may want to ask, is there a way to know which is right? Is there a way to verify that the extra dimension exists? Of course, physics is not a fantasy. It is to rely on evidence to speak. If the extra dimension is true, they must leave a trace somewhere, even if these traces are faint. Physicists are working in several directions. Go for these traces. The first direction is to measure gravity. Newton said, "The strength of gravity is inversely proportional to the square of the distance. The distance between the two objects is doubled. Gravity is reduced by 1/4. This is called the law of inverse square ratio, suitable for landing from apples, to all the situations in which the planet orbits the sun. But if additional dimensions exist, and gravity can leak in, that was at a very small distance. The decay of gravity should be faster than the inverse square. For example, doubling the distance. Gravity may decrease to 1/81/16. Depends on having several additional dimensions. What physicists do, it is to measure gravity over a very small distance. See if it still abides by the law of inverse square proportion. This experiment is very difficult to do. Gravity is inherently weak. It is weaker at small distances. It is easy to get covered by things like electromagnetic forces. And the experiment must isolate all vibrations and interferences. Otherwise, it is impossible to guess it at all. Physicists have created an instrument called a torsion scale. Imagine a filament hanging from a crossbar. 2 small balls hang from each end of the crossbar. You put a mass block next to it. The balls are pulled by gravity. The crossbar will twist. By measuring the angle of torsion, the magnitude of gravity can be calculated. The most sophisticated torsion scale experiment today, a scale of about 50 microns, has been measured. No abnormalities in gravity have been found. This means, if an additional dimension exists, they are either smaller than 50 microns. Either it was hidden by something, but the experiment continues. Every few years, someone breaks records. Push the scale down a little more. One day, either an anomaly is detected, or at an extra dimension of activity space, compressed to almost zero. The second direction is the particle accelerator, CERN. There is a Large Hadron Collider, LHC for short. It is currently the largest particle accelerator in the world. He can accelerate protons to close to the speed of light, then let them collide head-on. Collisions generate enormous energy, concentrated in a small space. This high energy density may reveal the existence of additional dimensions. How to reveal it? One way is the loss of energy. The energy before and after the collision should be conserved. You know how much energy goes in, how much energy you measure. If the two sides are not on the same page, some of the energy disappeared out of thin air. Then he may have slipped into an extra dimension. The detector is installed in our 3-dimensional world, cannot detect things in the extra dimension. So if a particle runs into an extra dimension, for us, it's a loss of energy. Physicists have carefully looked for this signal in the LHC. So far, no findings. But that doesn't mean that the extra dimension doesn't exist. It may just be a need for higher energy to open their doors. Another, more exciting way is to create miniature black holes. Black holes usually require enormous mass to form. For example, a massive star collapses. But if additional dimensions exist, and gravity is smaller than we think, strong, the high-energy collision could be in a very small area, create conditions where gravity is strong enough, forms a miniature black hole. This black hole is very small, extremely short lifespan. According to Hawking's theory, black holes evaporate and release radiation. The smaller the black hole, the faster it evaporates. Microscopic black holes may have formed after they form, less than -10 to the power of 26. It evaporates, leaving a bunch of particles to eject out. This particle ejection has unique characteristics. It is different from ordinary collisions. If the detector sees such a signal, it is ironclad evidence of the existence of additional dimensions. The LHC has been looking for it for many years. No signal of a miniature black hole is seen. Again, this does not mean that they do not exist. It may just be that the energy is not high enough. The third direction is in space. The Big Bang occurred 13.8 billion years ago, leaving an afterglow. It is called cosmic microwave background radiation. This is a faint electromagnetic wave that fills the entire universe. The temperature is only about 2.7 degrees above absolute zero. This radiation, it can be seen as a picture of the infancy of the universe. In his subtle patterns, hidden information about the geometry of the universe. If an additional dimension exists, they may leave marks on these patterns, affect the long-term drop of temperature, affects the way matter gathers. Cosmologists have been carefully analyzing data on microwave background radiation. See if there are any signs of additional dimensions. So far, no conclusive conclusion has been reached, but research continues. Another clue is gravitational waves. Gravitational waves are ripples in space and time, produced by violent celestial movements. For example, two black holes merge. In 2015, for the first time, humans directly detected gravitational waves. It was discovered by the LIGO detector, if gravity can leak into additional dimensions. When the gravitational wave travels through the universe, may exhibit anomalies. They may decay faster than expected, or the frequency is strange. Drift. Existing gravitational wave detectors are not sensitive enough. I can see this subtle anomaly, but future detectors will be stronger. Maybe it captures an extra dimension of signal. There is also dark matter and dark energy. Most of the matter in the universe is dark matter. Most of the energy is dark energy. We know they exist because of their gravitational effect. It affects the expansion of galaxies and the universe. But we don't know what they are. Some physicists believe dark matter and dark energy may be related to additional dimensions. Like what? Dark matter may be particles hiding in additional dimensions. Dark energy can be a geometric effect of an extra dimension. If this is true, the experiment to study dark matter and dark energy, the presence of additional dimensions may be inadvertently revealed. Up to now, all these searches, no direct evidence of the existence of additional dimensions has been found. This is a bit disappointing. Some people also questioned if the extra dimension really exists. We should have seen them a long time ago. Why is it so hard to find? But physicists are not discouraged. They will tell you, not finding does not mean not being there. There are many reasons that can be explained. Why haven't we found it yet? Maybe the extra dimension is too small. It is smaller than the scale that our experiment can achieve. Maybe they were hiding too well. Higher energy is required to turn on. Maybe we're looking in the wrong direction. A different way of thinking is needed. And every search is valuable even if it doesn't find it. It tells us where the extra dimension can't be. Help us narrow it down. Guide where to go next. This is how science progresses. It is not a quick answer. Instead, it is a step-by-step to eliminate the possibility of error, approaching the truth. Having said so much, you may want to ask, if one day it really proves that the extra dimension exists, what does it mean? First of all, our understanding of reality must be completely rewritten. For hundreds of years, we think of three spatial dimensions. At a time dimension, it's everything. From Newton to Einstein, all the laws of physics are written in this framework. But if additional dimensions exist, this framework is too small. All we see is a slice of reality, one projection and one shadow. Imagine a group of flat people living on two-dimensional paper. They can only move forward, backward, left and right, cannot move up and down. They think that paper is the whole universe. One day, a three-dimensional sphere crosses the paper. What will the flattener see? First a point. Then there is a circle that gets bigger and bigger. And then it gets smaller and smaller. Finally disappeared. Flat filmmakers will find it inexplicable. How can a circle appear out of thin air? It disappeared out of thin air. But if they know there is a third dimension, everything is easy to explain. The sphere did not disappear, just left the paper. I went to a place where flat people couldn't go. If we find that additional dimensions exist, a lot of strange things in physics, it may be easy to explain at once. Why is gravity so weak? Because it leaked into an extra dimension. What is dark matter? It could be a particle hiding in an extra dimension. Why is dark energy driving the expansion of the universe at an accelerated pace? Probably geometric effects of additional dimensions. These puzzles have tormented physicists for decades. Maybe the answer has always been there. It's just that we can't see it. Secondly, the dream of unifying all forces may finally come true. Physicists have always wanted to find a theory of everything. Combine gravity, electromagnetism, strong nuclear force, and weak nuclear force, all in the same frame. Describe it with the same set of equations. This dream began in the time of Einstein. I haven't caught up with it for 100 years. Why is it so difficult? One reason is gravity. The other three forces are too different. It is too weak, and its mathematical structure is also different. Every time a physicist thinks, stuffing gravity into the framework of quantum mechanics, the equation collapses. But if additional dimensions exist, everything is different. Karuza found out that year. A 5-dimensional equation can describe both gravitational and electromagnetic forces. String theory is in 10 or 11 dimensions. It can fit all the forces and all the particles into it. Additional dimensions may be the key to unification. In our 3D perspective, the four forces look completely different. But in a higher dimension, they can be different manifestations of the same thing. Like a cylinder, it is rectangular from the side. It is round from the top. It's actually the same object. If the theory of everything exists, it almost certainly needs extra dimensions. Take it a step further. If an additional dimension exists, our understanding of space and distance also needs to change. In 3-dimensional space, from Beijing to New York, the shortest distance is along the arc of the Earth's surface. You can't go in a straight line, because the Earth is in the way. But what if there is a fourth spatial dimension? Imagine a piece of paper dotting on it. The two dots represent Beijing and New York. On paper, you have to follow the paper. But you can fold the paper. Let the two dots come together. Then you poke a hole. Thread directly from one point to another. This hole is a wormhole. A shortcut through high-dimensional space. In a universe with only 3-dimensional space, wormholes sound like pure science fiction. But if there is a higher dimension, wormholes become mathematically possible. Einstein's equations allow it to exist. Of course, in theory, it may not mean that there really is. Even if wormholes can exist, they can also be unstable. Or we need strange substances that we simply cannot create to maintain. But at least, the extra dimension makes the wormhole no longer pure fantasy. Rather, it is an option that physicists can seriously consider. Imagine this. If in the future, humans have really mastered the technology to travel through high-dimensional space, from Earth to another star system, it may only be a step away. The scale of the entire universe will be different. And the multiverse. String theory allows. Extra dimensions come in many different shapes. Each shape corresponds to a different set of physical laws. different particle types, the intensity of different forces, different physical constants. This means our universe, it may just be one of countless possibilities. Imagine a huge landscape. There are countless valleys in it. Every valley is a universe, has its own laws of physics. Our universe happens to fall in one of these valleys. So what we see is this set of laws. But in the valley next to it, the laws can be completely different. Atoms there may not be formed. The stars there may not burn. There may be no life there at all. This is called string theory landscape, or the multiverse. Some people think this idea is beautiful. He explained why our universe is just right for life. Not because the universe was designed for us, but because there is only a universe suitable for life. Only then will someone ask this question. Other universes that are not suitable for life also exist, but no one knew about them. Some people also find this idea annoying. If anything could happen in a universe, then nothing can be predicted. Nothing can be ruled out. Science becomes storytelling. This debate is still inconclusive. But like it or not, the multiverse is a logical consequence of the extra dimension. If an additional dimension exists, sooner or later we will have to face this problem. Finally, there is a somewhat philosophical meaning. If an additional dimension exists, then our senses are incomplete. We think we see the whole picture of the world. In fact, only one slice was seen. This is nothing new. Physics has been telling us. Our intuition is unreliable. We feel that the Earth is stationary. In fact, it is traveling at a speed of 30 kilometers per second. Rotate around the sun. We feel that time flows evenly. In fact, time will be bent by gravity. The flow is different in different places. We feel that matter is solid. In fact, the inside of the atom is empty. Almost all of it was empty. Extra dimensions are another example. We are locked in three-dimensional space. It's like a fish locked in water. Fish have never seen land. It does not mean that land does not exist. It's just that fish have no organs to sense the world above the surface. We probably do the same. Extra dimensions may be all around us, in every point of space, under our feet, in our hands, but we don't feel it. It's like not being able to hear ultrasound. Invisible infrared. This is not a frustrating thought. This is a humbling thought. The universe is bigger, more complex, and more layered than we think. We're just starting to peel back a corner of it. Now we return to that fundamental question. Does the extra dimension exist? Honestly, today in 2025, we have a whole bunch of circumstantial evidence pointing to it. Gravity is too weak. Mathematical equations require more dimensions. Different theoretical frameworks are calling him. These clues are too dense. It doesn't seem like a coincidence. But we don't have direct evidence yet. None of the experiments jumped out to see gravity is on this scale, deviates from the law of inverse square proportionality. Or look at the missing energy in the LHC. This is the state of science. We are on the border of knowing and not knowing. Take it one step further. Probably nothing may also open a whole new world. Some physicists are optimistic. They feel that the next 1 or 2 years, stronger accelerators for more precise gravitational experiments, more sensitive gravitational wave detectors, more detailed cosmological observations. There is always a tail that catches an extra dimension. Some physicists are also cautious. They pointed out an additional dimension of string theory prediction. It may be as small as the Planck scale. Humans can never create it, an instrument that can detect that scale. If so, extra dimensions may stay mathematically needed forever, but the state can never be confirmed. But regardless of optimism or caution, none of the physicists gave up. They are still knocking on the wall little by little. In fact, if you look back at the history of physics, you will find that it has been going this way all along. Mercury's orbit is slightly off. The bias is very small, 1% of the degree, but this small deviation. Finally, we are given the general theory of relativity. It gives us a new understanding of the nature of gravity. The curve of black body radiation is not correct at the high frequency end. Physicists are driven crazy by this question. Finally, Planck proposed that energy is one by one. This is how quantum mechanics was born. Every big breakthrough, it all started with something wrong. There's something wrong. There is a phenomenon that cannot be explained. There is an equation that cannot be put together. Scientists have been chasing this wrong thing. Chase to the end and open a new door. Now gravity is so weak. It's just that something is wrong. Equations require additional dimensions to be self-consistent. It's another thing that is wrong. Dark matter and dark energy cannot find an explanation. It's the third wrong. These things may not be related to each other. Each has its own answer. But it is also possible that they point in the same direction. Our understanding of space can be wrong. We may have missed some dimensions. Physicists are chasing this line. Sewell has been chasing it for almost 100 years. I haven't caught up with it yet. But the direction is getting clearer. The scope is getting smaller and smaller. If it is really proven that additional dimensions exist in the future, that would be another great leap forward in human cognition. We'll know. The three-dimensional space we have thought since we were little. Just a low-dimensional slice of real space. We will know that the weakness of gravity is an illusion, because it is scattered to places where we cannot go. We will have a new set of physical theories. It can explain the universe from the smallest particles to the largest. It can unite all forces and all matter. That would be the holy grail of physics. Of course, it may also be a future experiment. No evidence of additional dimensions has been found. Maybe they really don't exist. Perhaps the whole framework of string theory is wrong. Then physicists have to change direction. Go find another way. Science is just that. He doesn't guarantee that what you're looking for exists. He only guarantees that you can find it through strict methods. Sometimes I found it. Sometimes you can't find it. Not finding it is also a result. It is also progress. But at this moment, we are in an exciting position. The LHC is still running. The next generation of accelerators is already in the works. Gravitational wave detectors are being upgraded. New equipment will also be placed in space. Dark matter experimental cosmology surveys the sky and precision measurement of gravity. All these directions are advancing at the same time. Maybe in 10 years. Maybe in 20 years. Maybe 50 years from now. There is always a clue that will come out. Maybe a small signal, a faint anomaly, like the little deviation in Mercury's orbit back then. By that time, we'll know. Is the extra dimension really there? Waited for us for 100 years. Just wait until we finally find him.